open up what I am going to.
Mm-hmm.
Okay, I'm in the right place. All right, guys. So the goal of this presentation here is just to get you guys caught up with Hugging Face here and their Transformers library. If you've been playing with BERT, then chances are you were using PyTorch pre-trained BERT before, which actually is Hugging Face as well. But they've since grown that out into a framework agnostic implementation that will work for either PyTorch or TensorFlow, and they've really built a best-in-class library for all things transformer-based.
Who is doing Hugging Face? Which group of people?
So Hugging Face is the name of the company.
Uh-huh.
Transformers is the name of the library. So Hugging Face itself is a company out of New York City that builds chatbots and AI. And in building some chatbots and AI, they have 3 different implementations on the App Store that you can download and play with that have in-app purchase that. But they are, I know they have a big footprint in Asia, where I'm not sure how familiar you guys are with like business use cases like that in terms of chatbots here, but like the literal joke for in China is they call talking to AIs toilet time. Like that's what they do on their phones when they're in the bathroom is they sit there and chatbots that are there's a million different implementations there.
What do they squeal talk?
Toilet time. Essentially when they're in the bathroom, they open up their phone and they'll talk to different AIs. That's a much bigger, much more normal thing that's over there that is kind of culturally, they're a bit nicer and don't try and break them like Americans do. But that's a whole other topic here. So in that area, what Hugging Face did is they've been to a lot of competitions for NLP, NLU, NLG, and they kept winning a bunch of them here. So essentially, they realized, hey, wait, everybody else wants to use our code, our framework. They were one of the first implementations of BERT in PyTorch that was done in a very clean, open source way. So they ended up kind of putting it all together here. And I will pull up, let me pull up, let's find, here we are. So they put together a pretty awesome.
I don't know who is that. Is that, since we're recording, let's do it a bit cleaner. That's maybe Suji?
Yes. So Suji, would you mind muting here? Or Mark, you can, if he's not in front of his computer, you have the ability to mute anybody.
Okay, yes, I'll do it.
There we go, cool. So their website has a ton of great documentation for different things they've done here. Like, yeah, I'm pretty sure they won a conference on co-reference resolution here. They've got a ton of good stuff here. What we're looking for is transformers. And it's quickly become a very big deal. It's got something like 22.1 thousand stars on GitHub, just under 5K forks here. So it's very easy to use. We'll go over that in a second here, but I want to walk you through the documentation first. So essentially, some of the things they've tried to focus on, you'll notice in today's presentation, it's got a very concise Keras-like syntax. This is a big deal. This is the only library that is out here for something advanced BERT or transformer-based models that is language agnostic. The other option here would be to use the Google implementations, which we can download from TensorFlow Hub. Personally, retraining those is like just dealing with the architecture of it here. That's, you know, I think anybody's own personal health. If you played with it here, it's not very well done. Not very clean, a lot of boilerplate, very easy to run into error messages, cryptic, that don't tell you a lot here. So they've abstracted a lot of that away and made it very easy to start from that here. You'll see that they have 10 different architectures, over 30 pre-trained models. So for instance, basically it's like, cased and uncased for a lot of them here, and then maybe some smaller sets here, or trained on different data sets here. But it's very, very easy to go back and forth with it here. So again, this is just on their GitHub, still just right here. And we have a ton of good stuff here that they have. It's just pip install transformers. So what I found is a lot of people, if they're following on tutorials to use BERT, probably already have this installed. They don't even realize they're using Hugging Face. They wrote the transformers library. They have a ridiculous amount of examples in their examples folder. They even give recommendations for if you want to run this in edge computing on a mobile device. And here's the full list of...
Just installed it, Michael, as you were talking. But my question is, does it assume a certain version of TensorFlow? Like 1 point something or 2?
I believe it's... So I'm using TensorFlow 2. Since TF2 came out, I haven't looked back. It's much cleaner syntax, much easier to use. But if it is TensorFlow, I think it's agnostic to it here. I know TensorFlow 2, you're safe. If you're running code in TensorFlow 1, there is a way agnostic to Hugging Face using, I think, TF1.
I just checked. I also have 2, so it's more.
So, Mike, Suji here. Quick question.
Yes.
So, are you using this, or are you using TF2? I'm kind of curious about what your personal experience is.
So I started using TF2 mainly because originally Hugging Face only had a BERT model in PyTorch, and it was just a single library. It was, PyTorch pre-trained BERT is what you saw in like all the Kaggle competitions and everything. And it was just this one little library for that here, and it just had, a couple BERT models here. They've since expanded that out to include, XLNet, DistillBERT, Albert, all kinds of here. So now I use this exclusively. Now for BERT, I exclusively use Hugging Face. I would argue that most of the industry does too. The fact that you can go from PyTorch to TensorFlow seamlessly in one line of code is awesome, because as you know, most people do their research in PyTorch, but productionization is all TensorFlow. So that was a challenge for people, is they would start with one, and they would either, like, if you're a TensorFlow practitioner, I'm sorry, go ahead.
No, I was, on the PyTorch TensorFlow. So the way I've done this is using Keras.
So if you're using TensorFlow 2, TensorFlow 2 and Keras are the same thing.
Okay.
So TensorFlow 2's main change is it Kerasized everything. So if you haven't updated TensorFlow 2, I highly recommend it. You no longer have to get a session object. You no longer have to create a static computational graph. The boilerplate code all disappears. Everything is eager execution is enabled by default. From both a coding perspective and a teaching perspective, TensorFlow 2 will save you more than half of the time that you were using before. And they have a bunch of scripts that'll help you port your code over here, but it's all very easy to do, and it has a simple Keras-like implementation. So we'll see with this here, it's going to work the same way. I will show you guys this here, because when you're teaching classes, this will make your life a lot easier. But first, let's do a tour here of the language. So here's all the different models that we can load up here.
So they
there's a lot, right?
Yeah,
Yeah, and these are all pre-trained, right? So these are all state-of-the-art, with the unsupervised pre-training handled here that are loaded up. And we're going to walk through. I've basically taken this code from here, and I've done a bit of modification just to add in some more comments and help people understand it a bit more here. And I'll grow this out a bit as I have more time here. What I didn't realize is that it's going to take me, even with the GPU, it took about 40 minutes on this. So that ate up a lot of time for me last night. But so this is just a simple fine-tuning example here, where they take a BERT model for sequence classification. So they're starting with the basic BERT model trained on cased English data. Here, let me switch over to mine.
So I'm sorry to interrupt, but you have a GPU on your computer, don't you?
Do I?
A GPU. Do you have a GPU on your computer?
Yes. So I have.
Must. Should you use a cloud GPU, or should you really install?
For this, I would use a cloud GPU. I just set it running on a laptop here last night at about 1 a.m. and wanted to finish up the notebook here. But yes, I would highly recommend using the cloud for this here. This will be so on a 6 gig 10 GTX 1060 on this laptop. It took about 38 minutes to debug. I would assume on my 1070 Ti on my desktop, that's a bit of a bigger rig. It'll probably be done in 30 minutes. But you know, on like a T2X large cluster or something like that in AWS, this AWS is going to run in, you know, a couple minutes.
Much faster, right? So other than the money considerations, it is better to do the cloud. Okay.
Yeah, yeah, absolutely. And I'll say this: if you're if you want to keep, you know, money considerations, like these cloud bills could run away with you real quick, right? Learning.
Yeah.
Then there's 3 options that I would recommend here. The first is Google Colab, gives you something like 12 hours a month on their GPU acceleration, GPU or TPU.
Colab also gives you TPU, but I could never see that really is any advantage unless this TPU is real.
TPUs are going to work a bit faster on some things here, but there's ways to like burn that too. I think it has to do with like, that's why you see people using powers of 2 in like their layer architectures, because it has to do with how it's loaded.
So Mike,
go ahead, Suji. One more time. I'm sorry, CG, if you're talking, I can't hear you.
I also cannot hear. No, he disconnected.
Oh, okay. Cool. Well, if he pops back on, I'll be happy to answer his question here. Otherwise, let's roll through it a bit here.
Sorry, Mike.
So,
sorry, Mike. Sorry, what I was asking. Sorry, maybe. Sorry, I cut out. Like I know Colab gives you free GPU, right? Is that good enough for running something like this, or do you need to go get the paid version?
So yeah, it does. It does give you that here. It should be fine. So it depends on what your use case is, right? If you're experimenting on something here and you're just trying to play with it, I would do that. My understanding for how that goes here is that for the free tier in Colab, you know how AWS and Google Cloud let you bid for like basically excess server time. I think that they're giving that away. So if it's a peak user time here, I've had it where it's like, oh, it clearly isn't being accelerated by a GPU. I'm not on a back server.
Mm-hmm.
You can tell because you can try and get the GPU. I've seen that happen. But generally, I'd say about 90% of the time when I prototype something and I need a cloud GPU, I'll use Colab and Keras to do it. So the other option there is Kaggle. Kaggle gives you in a Kaggle kernel 30 hours a month. And that is a bit more steady. That I don't think that I'm pretty sure is dedicated. Not in the sense that you can have like a dedicated instance, but that I don't think you lose kind of preference in line for a server that is GPU backed. It does not give TPU, but again, not a big difference in terms of runtimes for us here. And it's very easy to share and make private Kaggle kernels. So one benefit there is that our work, if you want to keep it private, it's still private. The third option, which is more, which is I think a bigger concern here, is something I'd recommend. Is that so I've had some friends that have raised rounds before they even raised a round. They talked to they're doing a startup now. They talked to all the major cloud providers, so GCP, AWS, Azure, and they asked, "Hey, we're starting startup. We'd love to build everything out on your stack. Can we have a credit?" And both AWS and Google Cloud offered them $100,000 in credit to build their startup stuff. So unless there's some reason why, you know, if there's some caveat that you can't use that for learning, which I would be very surprised here, I think that would probably be a good longer term strategy for you, Mark, to say, hey, we're going to do everything on your platform here. We want to, you know, we're AWS first. We'd like to do this. Can we have a credit, right, to build out our infrastructure?
That's awesome, but how do you get in touch with them?
I'll make some calls, and they make it pretty easy. I just need to figure out what route we go to do that here. but I know a couple companies that have done that here. So let me dig up that info for you, and I'll get it here. It's in the short term, like I would stick to Colab or just paying the cost of WS or something like that here. But that is something that I think that if we make a concerted effort, a couple of years or so, we could probably have
That's a great idea.
So just walking through the code here, I do want to point out some touch points for BERT. Or for any transformer model. Each of them come with their own tokenizers because again, they all tokenize differently under the hood in the different white papers here. So you have to be pretty cognizant that when you're getting the tokenizer, you're also getting the right, you're passing in the right model. So for instance, if I had BERT-based case as my tokenizer and the model was BERT-based uncased, we're gonna have a problem. Right.
Okay.
Similarly here, you couldn't use this for like distill BERT and BERT.
I noticed, Michael, when you started this, you used some kind of JBP command or something like that.
Yeah, that's just an alias for Jupyter Notebook.
Oh,
so
okay.
I'm running Windows subsystem on Linux, and that was just a bash alias I've set up here.
Okay, good. Got it.
But good eye.
Right.
So the main workflow you're going to see in using the Transformers library here is your tokenizer, your model, and your data set. And the data set is, if you haven't played with the TensorFlow datasets library, it is amazing. This is something that rolled out with TF2. Now you can create a dataset object where you're, and you just pass that object into your model instead of having to worry about splitting into training and validation sets or shuffling or things like that. Now you have a single object that is contained. It does all those things for you. I can't recommend it enough. The documentation on it is actually pretty good as well here. The nice thing about it for something like this is if you're working with open source data sets, like for this one here, we're going to use the Microsoft Research Paraphrase corpus, right? So we're going to train a model for sequence classification. And we're going to say if one sequence is a paraphrase of the other, then we can just very easily run this cell and it'll download them for, are you here? So these are lazy loaded. So if you don't have them on your computer, it will download the first time. It'll give you a nice, nice pretty green bar here. It uses QDM under the hood.
Mike, I'm thinking of in our work for Sky, we want to have our own data sets. And write some kind of API so that everybody gets standard data sets, not some random files. Would this TensorFlow data set be a good start for that kind of API?
So however we structure the data set that we're going to use is an open question, right? We can figure that out if we're going to use that as a tar file or a gzip file or just a folder full of text files. However we want to do it, that's that here. What essentially you can always load something in, right? You can always say like dataset.from tensor slices and just give it an array created or a list in memory. That's totally fine. There may be some other ways that we can do this too. For instance, serializing a TensorFlow dataset object.
So, Mike, what is this dataset? GLUE MRPC. What exactly is the dataset?
So GLUE is General Language Understanding Evaluation, and MRPC stands for Microsoft Research Paraphrase Corpus. So this is a link, but I think that's just down like here. So essentially, this is a research project that the Microsoft team put together, where it's a corpus for telling if a sentence is a paraphrase of another, right? So is this sequence semantically a paraphrase? They're both quite large here, but this was just...
Sorry, I'm a newbie of this one. Can you tell me a little bit more about the actual data?
Yeah, sure. So the data is going to look like this. So you're going to have sentences here, and it's going to say, like, for instance, sentence 1 is a paragraph, is a paraphrase of this here. I should probably switch these. I should say 0 here. But essentially, and then you'll have other sentences that are not, right? They contain different information. Like if I said, Mark and Tim went to a movie, or Mark and his friends went to movies, that's a paraphrase. If I said, Mark and his friends did not go to a movie, well, even though that's going to have 90 something% card similar. It's going to overlap very heavily in terms of what the words contained in there. We can tell from a semantic meaning perspective, the sign points in the other direction. So this is actually a very challenging
but you, Mike, you know exactly what we're working on, and that is the answer to what we're doing, right?
So yes, paraphrase, summarization, and question answering. And by the way, one thing I'll point out here is that if we go back to here and we go to examples, right, or let's just look right here. Where is it? They have a ton of implementations already done with this. So for instance, let's see that usage pipeline. I know it's here. Oh yeah, just here. So here we have some classic data sets, the IMDb data set, something like that here, distilling a BERT model down. So, this is where we get the machine engineering section. But BERT is big. Anyway, you can make it smaller through quantization. But, they have Squad for Stanford question answering set. They have named entity recognition, right? They have just multiple choice questions, things like that, and then just general language generation. This is where I think BERT is, or the Transformers library is perhaps the strongest, is it is really easy to do NLP this year. So if you want to do generative stuff, something like GPT-2, it's really easy here.
Michael, yesterday Tim was doing the presentation on the Glue leaderboard. And I wondered, of those 11 tasks there, does every team who submits also fine-tune for that particular set of 11? That's a lot of work to submit then.
Yes, it is. I believe they do. I think you can compete individually on a certain task in Glue. But since it's a generalized language understanding thing here, you're going to need many different things here, right? Because I can do something like next word prediction, but if I can't do co-reference resolution, well, then do I really have a generalized language understanding, right? So Glue is meant to be challenging.
Okay, it is. And Super Glue is even more so.
Yes, it is. So we can get into this more deeply when we talk about summarization and question answering in a future seminar. But for those are going to be two different benchmarks here. Summarization is the Rouge 1 data set, and the benchmark, and question is Squad or Squad 2 here. So, and again, these all come preloaded here. So this saves us a ton of time from, even if you ever had to download something from, the papers, like whatever old Web 1.0 academic
and I'm sorry we don't have
the
the data set any longer. That happened a lot.
Yeah. So,
and also, I see your notebook is so short compared to the other ones.
Yeah. So if you look at, like, for instance, the TensorFlow Hub implementation, it is 10 times as long as this notebook.
It is, yes, exactly right.
So this is why I was really excited about, like, hey, I got to talk to you guys about the Transformers library and Hugging Face, because I really think it is the future for this here. So what I like about this here, and I tried to highlight, is that, so for instance, this is all just using the data set object here, TensorFlow data sets, but it's quite easy to convert these things over. So, right, for instance, like, you do have to do, feature conversion, things like that here. That was, on your own, a very long, tedious process here that's very easy to mess up.
Yes, I was explaining to people, they were just taken aback.
So they've abstracted a lot of this away, right? Because this has to happen every time here. If we understand it, great. You can always dig into it, do it your own, or optimize it. But that's generally not the use cases we need for consulting, for teaching, for anything like that, right? Same with shuffling, batching. So this is going to create, like if you're done with Keras, you're probably used to creating generator objects. This is what it's creating under the hood. So this is instead of creating a generator object, or using like flow from directory or one of those methods you're probably used to using Keras. This is all very easy to do. Now, the model I want to point out, this is Keras syntax, right? But if you'll remember the model that we loaded up here, the model's coming from the transformers library, not from Keras, not from TensorFlow. So it all plays quite nicely together. It is all very easy to implement here. And all I had to do was, pass in again, same exact syntax as Keras here. It's you can't tell the difference.
It's brilliant. It that's what people should have done in the first place. But
yes.
Of course, it's easy to see when you see that solution.
Yeah, absolutely, right. Once you see it with this level of abstraction, I think they really hit the nail on the head.
So Mike, again, quick question here. So these converting to features, are they doing it right then, or are these like kind of featureized?
Yes, yes, they are doing this right here. The library is going to use lazy loading at every point possible here, but this is the first time we're calling it, right? So it will do this here. It is not going to download them as converted to features here. It does do the conversion right there. Right. So nice thing about it is you can use this in like pipeline, for instance. Absolutely, that is possible.
That's pretty cool. I mean, I look at the code; it just looks like a regular, TensorFlow code. I mean, actually,
right?
Keras code, I should say, right?
Yeah, exactly. I was
model compile, model fit. Yeah.
I thought I was going to have to learn PyTorch too when I was already pretty comfortable with Keras. Because everything I found for BERT was in PyTorch, right? Because it was the academic domains first, and when then TensorFlow Hub's implementation rolled out, oh great, and I look at it and it's just that's for machine learning engineers, not science. God, it sucks. And finally, Hugging Face brought over their implementation. They kind of hit the center here because they realized that, well, you really need to be able to go back and forth. Because this is an active area of research that we then turn around and productionize all the time, right?
So why do you think even the TensorFlow, the TF Hub example is kind of a little long-winded? I mean, why haven't they really taken advantage of the, API?
So I think the TensorFlow Hub example came out. The TensorFlow Hub example is still in TF1. And I know that because it makes you enable that, and because like you have to give the session object and create the graph, which you can still do in TensorFlow 2. You just have to enable some old TensorFlow 1 features. But yeah, so I'm sure they'll update it eventually. But I don't think they're going to actively try and compete. If there's this works with TensorFlow. So from TensorFlow's perspective, they're like, cool, as long as you're using TF, we're good. We don't care if our implementation of the model, we're more than happy to kind of share the wealth here. So speaking of that here we started with a TensorFlow model, right? And we're saving it here. Now, BERT for sequence classification is an object from PyTorch, right? So PyTorch is imported right up here. This comes from PyTorch. If you just import transformers and try and load this, you will get an error. So what I'm trying to show here, or better yet, what I'm trying to explain is their sample code that they showed, is that it's very easy to take an output from TensorFlow, and you can just mark it as, flag it as from TF, and it'll load it in just fine. Now, one big breaking change that if you played with PyTorch pre-trained BERT or one of those other models before, one of their older implementations. One of the big differences here is that if you're familiar with PyTorch, models have two states. They have a training mode and an evaluation mode. When you load a model and create it, it starts off in training. So they're actually smart enough to know, well, if you have a saved model that you're loading, you're probably going to use that for evaluation and inference, not training here. So it loads in the evaluation state. That being said, you can always, it's just a simple model.train or model.eval, switch them over. But they've really thought of the little things here. I like that a lot here. Obviously, I need to train this for longer, but or maybe switch the label. But yeah, I strongly recommend. Oh, I'd have to run.
So here, Mike,
I'm sorry, guys, but I get this message that this meeting will end in 30 minutes. Oh, 10 minutes.
Oh, no worries. I think we'll be done before then here, and if
So,
there's
so
no
I,
question,
I
we can
didn't
start
work to
it.
resolve that because I thought having L limit actually is good.
Yeah,
Yes.
Mark, yeah. We need
But
to,
in
I
the
mean,
future, should we do something about this?
no, Mark, I mean, you just need to use the right account. We actually paying for Zoom. I think you are using your free account.
I'm using your meeting.
Anywho, because
Okay, but
I
for
don't
now,
know.
it's 10 minutes.
Yeah, let's kind of get.
Later.
So, Mike, the last piece of code, right? I mean, so you got the model trained, right?
Mm-hmm.
And then, so I'm kind of, like, where is it spitting out paraphrase or not? Like, is it the?
It should be right here.
Okay.
I just, I need to load the tokenizer real quick here. Let me load this guy up.
Oh, no worries. Oh, yeah. Oh, no, this is good. I mean, I love, less than 20 lines of code, all right?
Yeah, absolutely. Right. Yeah. So for inference here, you can see that now, again, this is just pure. So you have encode plus, right? So, and again, the tensors here, you do have to specify, is this TF or T? Are you going to, do you want the tensors in PyTorch format or TensorFlow format?
I see.
But this is the BERT tokenizer we created above. And we're just passing in the two sentences that we want to see. Are they a paraphrase or not? Right. And the special tokens, we're setting true, so we can handle things like punctuation. They're creating predictions here. So here's where this is just vanilla PyTorch here, right? This is not Transformers library, although that's pretty easy too. I think syntax is going to be you can use TensorFlow syntax if you want to keep that across the board and like use their evaluation steps. You can do that too. But for PyTorch here, this is pretty much what you're passing in, getting the argmax and item for it here, and that's going to tell you. Then they're just using this to do some quick and dirty, actual formatting of what the. So if we run this here, let's. Oh, let's load that. All over the place.
And also, like, I know the code is pretty compact, but, every line, there's a lot going on, I can see, right? Yeah, looks like they kind of, give you this high-level APIs that kind of do all this lot of things internally. Yeah. So, I mean, as a practitioner, you can sort of, get it working. But like you said, when you teach somebody, you may have to kind of explain like each of these parameters and each of the steps, right?
Yes, yes, I agree completely.
Yeah. Like you mentioned, like the return tensor, it looks like pretty innocuous, but you know what I mean? It's makes a big difference, right? Yeah.
Yeah, you still have to know where some things are for sure, right? It's the other thing that I think is challenging about deep NLP that you do not see in other deep learning tasks like time series forecasting or computer vision, is that the architecture, the pre-processing, the inference tasks, they're orders of magnitude more complex when you're dealing with NLP, right? So, right now to check if something's a paraphrase, doing that requires a lot more boilerplate that is architecture specific than something like next word prediction or something like that. Here. So like if we look at, for instance, let's look at some of their code for running a question answering model here. They've written pretty good production quality code here. There's a lot to it. Now this is them using it here, so you can call this as a bash script. I think that's going to be a lot easier for you all here in training. So it depends on, I would essentially, in my mind, a successful consultation or let's say a week-long training or whatever in BERT or Transformers is not, the output is not this. They should not be able to do this. They're not going to have that level. The output is probably going to be two different things. One is the ability to fine-tune and train a model in something like this here, right? Which is going to look more like this, what we just wrote, right? This is fine-tuning. Again, the model we loaded, it was already pre-trained. We fine-tuned it on this data set. And then for inference, for a lot of those things here, it's going to be something like this, right? Where, hey, they have these questions, they have this other stuff here. how does this fit into their pipeline, right?
Yeah.
So how are they just calling these things here? So I would treat it separately. I would absolutely treat the training and the evaluation steps as two separate tasks.
Gotcha.
And as they start to bleed over, that's great, you know, but it's totally okay, I think, for from like a output standpoint of a training to say, well, they can do, you know, they can fine tune a model to their needs. They can use it. They have a path.
Yeah.
It may be brittle, their understanding of how to use it at first here, but that's okay, right? They're still light years ahead of where they were before.
Right. So let me ask you more of a, so this is good, right? I you know, this give me a pretty good sense of, you know, what the API looks like. So I'm sure like there are a lot of startups, you know, rushing to kind of, you know, do something with this. So since the models are already pre-trained, I'm kind of curious, what is the startup value at? You know what I mean? Because, you know, are they going to retrain on a specific data set? Because,
yes, great question. Yeah, so essentially, you know, transfer learning and NLP in any real usable sense here has really only been an option since the BERT paper dropped in October 20. So it used to be before your pipeline would generally be based around word to vec or doc to vec, right? You would do some sort of vector embedding space, and you would need a massive amount of data because you're training this from scratch, or you would do transfer learning from starting from something like the weights provided by you know, the GLOVE data set, you know, from the Stanford NLP group or something like that, right?
Okay.
So open source implementations of Word2Vec here. But Word2Vec is an embedding space. It doesn't solve all the tasks you need in NLP. It just gives you a better like vectorization step, right? So BERT was wildly better than everything else here. Before BERT, the best you were getting on Winograd schema and co-reference resolution tasks were something like 54%, like a point. BERT got to like 76%, right? And it's just better as we throw more data and compute at it, right? We haven't got all the juice out of the lemon yet. So now the use case for a company is you start from a model like BERT, you then fine tune on their data set of chatbot interaction, right? I'll give you, for example, that WeWork used here. When I was at Flatiron, I saw this paper. Zendesk tickets, right? So when you're in a WeWork, you write a Zendesk ticket for anything to happen. If the light is out in your office, if it's too cold, if you have a billing question, stuff like that.
Ticket, huh? Okay.
So that was just basic text classification, right? Now the people that were doing this here, you would get like the managers of a WeWork location would have to sort these by hand. Well, when WeWork did the math, they were like, this is $30 million of lost productivity annually. From people having to just spend time sorting. Does this go to my facilities person, or is this a sales question, or whatever?
Oh, I see.
So they had, they didn't have a million example data set, but they did have enough that they could start from BERT, fine tune on this, and then do human in the loop text classification.
So when you say fine tune, what does it exactly mean?
Fine tune means starting from the pre-trained BERT model, the transformer model, and then you're going to tweak the last layers, right? So just like how you can take Inception v3 or something like that in computer vision, chop off the last layer and say, actually, now you're just a hot dog detector, right? That's an example of fine tuning, right? Or last layer training. It's going to be the same.